comparing two different treatments on strawberries that are put into a freezer. They had 50 strawberries. They took 25 strawberries, put them in a package with some sort of chemical that would help keep them more red and more delicious looking. And then there was another package that did not have any chemical. And the strawberries were taken out after a period of time, and they were judged on how red and delicious they looked. So a low rating means that it kept its freshness or fresh appearance, while a low rating or high rating would represent that the strawberry didn't look very appealing afterwards, after it was stored in the freezer. Question A asked, how would you interpret the standard deviation from the control group? Well, standard deviation is a measure of spread or variability, and to communicate that a little bit better with the information they gave you here, follow some advice that I'm going to be giving you constantly in these tutorials. For the AP exam, two things that they're looking for is they're looking for you giving details whenever possible. Another thing that they want you to do is they want to make sure that you always connect the answers that you give in the context of the question. If you do that, I'll tell you what, you're going to save yourself a lot of points. And those are critical points that could make the difference between getting a 3 or a 4 or 4 or 5 or 2 or 3. So for this question here, even though it didn't say to do so, I think it's a good idea to find the sample average. Again, the details. You could find the average rating, discoloration rating from all the information there, add up all those ratings and divide by 25 strawberries, and you get that the sample average discoloration was 5.8. The question's asking how to interpret the standard deviation. Well, the standard deviation is about 2. So you could say that a typical or average discoloration could probably be found anywhere between 5.8 plus or minus that standard deviation. So we're talking about an average discoloration rating most typically showing up between 3.8 and 7.8. A little bit unusual to be talking about standard deviation when you don't have a set curve, especially a set normal curve. But the standard deviation still has meaning, and we've actually calculated standard deviations from binomial settings and geometric settings and the like. So that's example A worked out. For question B, it says, was it effective in the samples? Was the treatment effective? It says no calculations are required. Well, counting's not really a calculation, and that's pretty much what I would go for here. I mean, the more delicious looking strawberries are going to be rated between 1 and 5, and you can count it up. In the treatment group, there was 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 strawberries right there. So the majority of the strawberries, 15 out of the 25, showed a discoloration between 1 and 5, compared to looking at the control group where there was no chemical given. There's only 2, 4, 5, 6 strawberries that are rated 1 to 5. So just by looking at that, that would be a quick way to earn credit on question B. Question C is asking, basically, is it likely to be effective? Is the chemical likely to be effective for all strawberries using a confidence interval that was given to you? So the difference between the discoloration of the two was given by this confidence interval here. And since 0 is not in the confidence interval, you can say that it is likely that it will be effective for all strawberries. If 0 showed up in the confidence interval, then you could say that there's a chance that it doesn't make a difference if you apply the chemical or not. And if that was the case, then certainly the less chemicals, the better when it comes to my produce. All right, there's the first example, and we've got a few more coming up. All right, we're on to question number 2. This is, I believe, off of one of the earlier AP exams, and it was just a very straightforward, basic question about theory involving the Central Limit Theorem, also known as the fundamental theorem of statistics. We've got sampling distribution, of a sample mean, and they're telling us that the individual population, looking at it in an individual basis, the population is skewed. They're asking us to compare three different things: the center, the spread, and the shape. Now, first of all, you have to know this key phrase here, what a sampling distribution is. When I first started teaching AP Stats, I didn't push it as hard in terms of making sure students knew for sure what that actually means. A sampling distribution is a collection of all possible samples of a certain size from the population. It's something that you can't do in reality, but in theory, if you could collect every possible combination of, let's say, 30 people or 30 adults, it will change the distribution in several ways. Some things will remain the same. When you compare the sampling distribution to the original distribution, the means will be identical to each other. It's actually a formula that's given to you on the exam. Somewhere on the exam sheet it actually says that the sampling distribution is actually equal to the true mean. How do the standard deviations compare? Well, the standard deviation is going to get a lot smaller because we're talking about the standard deviation of the sampling distribution. That's how it's written in symbols. It's going to be less. It's going to shrink down quite a bit, and that's based on how much is in your population. So if the initial population has a standard deviation of sigma, the central limit theorem tells us that it's going to be sigma divided by the square root of n for the sampling distribution's standard deviation. For question number C, how do the two shapes compare? So that the initial population is highly skewed towards larger values. So I can basically show that in a series of maybe 2 or 3 graphs. If we have a distribution that's highly skewed to the right, which I graphed wrong, it's highly skewed towards the larger values. So it would be stretched out towards the larger values. That's our distribution from the individuals. If you actually started doing a sampling distribution and started taking collections of, let's say, 20 or 15 individuals for each sample, you end up getting something that's starting to look more normal. So it might end up looking maybe something like that. Whereas when you increase to something that is above 30, the central limit theorem tells us that it will be perfectly normal, regardless of what the shape looked like on an individual basis. The central limit theorem will shrink down the standard deviation, but will hold the mean at exactly the same mark as the initial population's mean. That might actually take a little bit more to explain, and that's something that your teacher can do, or if necessary, ask me if you know me in the 3D world.